Alright, this is still Unit 6, Lines and Triangles, and this is Day 3, Classifying Triangles and Angle Theorems. On this first example, talking about isosceles triangle, it says that the base of the isosceles triangle is segment KL. What that tells you is that segment KL is the side that is not congruent. The other two segments, KM and LM, those are your legs of the isosceles triangle, so those are your congruent parts. So what I would do is go ahead and say that 4D minus 13 equals the 12 minus D. And solve for it from there. I'm going to add D to both sides to cancel it out from the right. Add the 13 over. And divide by 5. D is equal to 5. It says find the measures of the sides though, so this is actually not enough. So the measures of the side, KM and LM, end up both equaling 7. Plugging that 5 in over here to either of them, both of them if you like. KL equals 11. So you'd always want to answer what the problem's asking for. On example 2, we have an equilateral triangle. So to find x and y, we'll set things equal to each other. Since there's two unknown variables, I am going to have two equations. And as you start to look through here, no matter what two sides I set equal, I'm going to be stuck with two variables. So let's go ahead and say maybe that 3x plus 7 equals 2y plus 3. And let's also say that maybe 2y plus 3 equals 6x plus y. Alright, and now I'll actually go ahead and work with these two equations. I could have also made the equation 3x plus 7 equals 6x plus y, but I've already got two equations and two unknown variables, so that's going to actually be good. The way I'm going to go about this personally is you can use substitution, elimination, you can get them into y equals and throw them in your graphing calculator. Personally, I'm going to take the time to get them into standard form by subtracting 2y over to the left, subtracting 7 over to the right, and on this purple one over here I will subtract the 6x over. I'll still have the 2y over there, but whenever I subtract y over, that's going to become 1y, and then I'll subtract 3 to the other side. And now I can work with these as far as like elimination goes. Personally, what I'll do is it's easy to eliminate the x's or the y's here. I'm actually going to eliminate the x's by doubling this one and adding it to the purple one. So now I have positive 6x. See, the x's will cancel now. Minus 4y equals negative 8. And now when I add those together, I get negative 3y equals negative 11. So y equals 11 thirds. Alright, now that I've gotten y, some people are actually tempted to go back and find an x through here. And in fact, you don't need to do that. It said it wanted the measures of the three sides. So what I'm personally going to do is I'm going to take this y value I just found, throw it in here. When I find the measure of GH then, I would actually have the measure of all three sides. Save yourself some work, you know. So GH is equal to 2 times 11 thirds for y, that I just calculated, plus 3, and just simplify that down. And that's going to be 22 thirds plus 3. I'll change the 3 to being a 9 thirds, and so I'll get 31 thirds. Or you could say 10 and 1/3 if you'd rather have a mixed number. And that's not just the measure of GH, that's also the measure of FH, and that's also the measure of FG. And they all equal 31 thirds. Again, didn't really need to go and find x, because once I found the y, I could just plug it into this one. I plug it in, everything's there. Alright, here's our proof. We are going to actually be proving the triangle angle sum theorem. That it says that the three angles to a triangle will always add to 180 degrees, their measures will. And we're going to actually take a moment to prove that. Now, I've been given this triangle Haven't really been given enough information to actually get this proof done, and that's where something like an auxiliary line can really come in handy. And an auxiliary line can be a line that you add in to make the problem easier to do. And you are allowed to do such things so long as you're not changing what has been given. So I added in line L right here in red. That's going to be parallel to line AC. So I've not changed the given really. I've just thrown this line in here. That will help us in doing this problem. And I'm going to add that in on my given stuff right here. Typically when you do an auxiliary line, you'll actually write it as its own step that you through any 2 points there is exactly one line. That would be your justification. But here I'm just going to make it an additional part of my given just for practice sake on this proof. Now we're going to go forward and actually prove that measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And how I'm going to do that is I'm actually going to add in a couple more labels for my angles. I'm going to label angles 4 and 5. The relationship that really sets off this proof is up top here. The angles 4, 2, and 5 add to 180 degrees. So for statement 2, I'm actually going to state that measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180, and that's by supplements theorem. Together, those angles created a line, so that's going to be 180 degrees. That's the reason why I'm able to say that the measures add to 180, something that's already been proven in this course. All right, now, where to go from there? We're trying to relate angles 1, 2, and 3. This relationship, though, is really nice, and it's going to come in handy in just a minute for us. The reason why is when you look at angle 4, it's got to be congruent to angle 1. We know this because these two lines, line AC and line L, were parallel, and 4 and 1 are alternate interior angles. So I'm going to go ahead and say that angle 1 is congruent to angle 4. While I'm at it, I can also say that angle 3 is congruent to angle 5 for the very same reason. So this is by alternate interior angles theorem. We'll abbreviate this a little bit. Alternate interior angles theorem. Now what I'm going to go ahead and do is, this is talking about the angles being congruent. I am going to mention that their measures are equal. So the measure of angle 1 equals the measure of angle 4. The measure of angle 3 equals the measure of angle 5. And that is by definition of congruent angles. Now I can make use into the equation that I had earlier. Definition of congruent angles. And now where this proof wraps up is going back to the second equation. I'm going to rewrite it down here, but I'm going to change things in it. I'm going to create what I was trying to prove. That now I can show that the measure of angle 4 can in fact be replaced with the measure of angle 1. I already had the measure of angle 2 in there, and I wrote measure of angle 4, my bad. Measure of angle 1, replaced it. I already had the measure of angle 2 in that equation, and I can take the measure of angle 5 out and replace it with the measure of angle 3, and those will equal 180, and this was substitution property that I just used. And that wraps up our proof. That's the reason why the angles of a triangle always add to 180 degrees. If I ever need to use that information again in a proof or a justification, I don't need to redo the whole proof. That proof is called the triangle angle sum theorem, that the angles of a triangle, their measures add to 180 degrees. Alright, that comes in really handy on a problem like this where I could actually start to find angle 1 right here by taking 43 and 74 off of 180, since the measure of angle 1 plus 43 degrees plus 74 degrees equals 180. So that would tell me that the measure of angle 1 is actually 63 degrees. Put a little note inside the figure here. While I'm at it, if I'm trying to find angles 2 and 3 as well, then the measure of angle 2 would also be 63 degrees by vertical angles theorem. All right, and now I could actually go forth and find angle 3 by the same process I did for angle 1. That the measure of angle 3 plus 79 degrees plus the 63 degrees I just found is equal to 180. And when I do 180, taking off 63 degrees and taking off 79 degrees, I get 38 degrees. There I go. These are my answers, and I'm done with this problem. Just go ahead and move it over there and circle it up. There's my 3 unknown angles. All right, here is my second proof of the day, and this is the exterior angles theorem that I'm going to prove. The exterior angles theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. In other words, in this figure, the measure of angle 1 here will equal the measure of angle A plus the measure of angle B as they have written right here. That's a good example for your notes. So what we're going to do is we're going to prove that. We actually don't need an auxiliary line. We actually have what we need right here. Where I go with this proof is relating what these things add to. For instance, let's take a look at this angle 2 that I threw in here. The relationship of angles 1 and 2 is that they add to 180, and that's by the supplements theorem. Now, hopefully, I can relate angle 1 somehow to A and B. And I can, and the fact is that when you look at angle A and angle B, there is an equation that involves it that also equals 180 if I add in angle 2 with it. So I can say, for step 3, that the measure of angle A plus the measure of angle B plus the measure of angle 2 equals 180. And that was by the triangle angle sum theorem. I'm referring to a theorem I've already proven. So I'm just going to write down the name of that theorem so I don't have to reprove it. Triangle angle sum theorem. Very helpful to study your theorems and postulates so you'll know the names of them when you're on a quiz or a test. Now, both the measure of angle 1 plus the measure of angle 2 and the measure of angle A plus measure of angle B plus measure of angle 2, they equaled the same thing, which was 180 degrees. So I'm going to write that they equal each other. And that you could call that transitive or substitution property. Please don't put both. That's kind of tacky whenever y'all were doing that on your last quiz. All right, and so I'll call that transitive property myself. All right, now remember what our ultimate goal is that the measure of angle A plus the measure of angle B equals measure of angle 1. The only thing in the way here is this measure of angle 2, but the cool news is it's present on both sides. And if you subtract it away, it will cancel, and you would simply be left with what I was trying to prove, the measure of angle A plus the measure of angle B equals the measure of angle 1, which is by the subtraction property. And I'm done with this proof. This is called the exterior angle theorem, and it's really, really useful on triangles whenever you have limited information. This is an example right here of where the the exterior angle theorem would really be useful. I have to find x in order to ever be able to find the measure of angle FLW. So let's start by finding x. Now, I don't have this third angle inside the triangle, so I'm not going to add to 180. But what I can do is I can take the measure of angle O, add it to the measure of angle W, and that will equal the measure of angle FLW. And so what I'll do is I'll go ahead and drop in an x plus 32 equals 2x minus 48. Substituting in my expressions, I will subtract the x from both sides and add the 48, that brings it up to 80, equals x. And now, to finish up the problem, the measure of angle FLW is going to be 2 times 80 minus 48. And when you simplify that down, the measure of angle FLW is 112 degrees, and we are done with the problem. That wraps up our day. I appreciate it very much. Let me know what questions you've got.